Greetings, friends. Welcome out to another chapter on our BLT report. This is Randall Nagy here, of course, and we are going to cover more than one operation from the built-in namespace, if you will. And in the built-in module today, we are going to be reviewing our coverage of eval in as much as it is much the same with some very important differences from the built-in exec capability as well. In order to help us understand and appreciate those differences, even better than the Python documentation allows us to do at the time of this recording, we're also going to go over globals as well as locals to see how we can use eval and xe so as to evaluate expressions as well as statements. One of the curious things about the help system at the time of this recording, once again, is that when we take a look at the eval as well as the help on xe, we see there are very little differences, and about the only one we can notice now is that eval uses an expression with a little e rather than a big E. We'll talk about that later on. And Python uses statements, once again, with a small s rather than a big S. So in the English language, whenever we capitalize something, and I tend to favor the German way of capitalization, because in our Python problem domain, there'll be a big difference between a capital expression and a lowercase expression, or a capital statement or a lowercase statement. Once again, we're covering that later on, but also missing from the documentation is the idea that another difference between eval is that eval will always return us something, usually expressed in terms of some type of Python object, while xe will always indeed return none. So if xe is returning none, we have to ask ourselves what we're doing when we execute anything. But before we get into the differences, of course, we should take a look at yet another one of the commonalities, because both xe as well as eval will take a dictionary, and that dictionary may be either from locals, a local scope at the time of our function call, or a reference to anything that we have in our global scope. The idea that globals is going to contain a reference is incredibly important, because when we have a reference as opposed to a copy, we're actually going to be pointing to or referring to something, in this case our global space, and that pointer to our present global space can change and be updated. Whereas if we're passing something in our local stack, for example, if we're underneath a function or somewhere nested underneath some type of gatekeeper, whether using a copy of locals changes our source is a matter of implementation dependency. And that's easy to understand because by definition, locals tend to be a bit transitory. In other words, when I leave a block, we don't have those same local definitions. So whether they change them or not, locals will allow us to hang on to something that we could use, and the same technique is going to be imposed by each implementation, keeping in mind that Python is a standard rather than simply CPython, which of course we've been using and I'll probably continue to use throughout my training. So no matter whether we use globals or whether we use locals, of course, we're going to get a dictionary back from either. The only difference is the impact changing that dictionary has on either our global or local scopes. Another concept we might have to review, and certainly will be a PyQuest card, is the idea of an expression. Once again, with a capital E. In other words, we're using Python's grammar or definitions or PEPs so as to note that using the capital expression, that an expression may have one or more statements, but a statement obviously will not. A statement is as fine a grain as we can get using the Python standard. So taking a look at our environment or preserving our environment, because locals and globals returns a dictionary, we can fake our own local and global environment, in this case using G. So I set up an environment that would be passed to eval, so that when we evaluate the statement of A, taking something from what's available to eval, and then adding 7 to it, we see that while our global variable of A was not changed, that what was returned was what would take place from the evaluated expression. So because exec always returns a none and eval always returns a result, we can understand that exec would have to put the result somewhere. And here again, by using our fake environment as G, we can see that not only did exec update our dictionary, but it also put a lot of other information into our environment, as we see at the bottom of this slide. So while exec and eval share a lot of the same details, certainly from a help string point of view, the fact that expressions or multiple statements can be used by exec is a lot easier to understand because we're going to be able to automatically update our environment by default, and therefore we have our results in our environment. Eval, however, is only going to use a single statement, and if we try to do anything else, we're going to have an exception because the built-in eval function returns one and only one result. So while it's a little confusing, of course, we can always run something through the old REPL mode and verify that if I, for example, said A equals a list using exec, all is well, and I expect my global environment to be impacted because there's no result returned. Whereas if I tried to do the same thing with evaluation, of course, we're going to get an exception saying that, hey, you're asking me to do more than a single statement. In this case, take an L value and assign it to the contents of an R value. And to tell you the truth, while you might think it could return our L value, because Python can be such an expressive language, we're going to get a syntax error as we see here. So our review questions include the all-new KA 2045 code evaluation, where we can choose the response to the built-in eval operation, can override globals, or 2, can use custom locals, 3, always returns a result, 4, can be used by compile, or 5, all of the above. KA 304-242 with the obvious life, the universe, and everything idea comes our ability to detect the difference between eval and exec. Is it that 1, eval, parses strings? 2, is the difference that exe runs programs? 3, that both eval and exe are used by compile? 4, is the difference that eval returns a result? Or 5, that exe returns a result? Pretty easy, even though it started out a little complicated. After reviewing the previous presentation, the answer may be obvious. KA 3045, another new advanced question, might be just as easy when we ask ourselves if Python's built-in global operation returns a string, a Boolean, a mutable copy, 4, a mutable reference, or 5, a potential object. Last question should be relatively easy, and it certainly is conceptual because we're using capitalized rather than lowercase, which allows us to ask ourselves if it is true that an expression may have many statements, but a statement cannot have many expressions. Once again, the answer should be obvious, but admittedly, even Python's own help documentation seems to confuse upper versus lowercase distinctions. Well, we sure didn't have to write any code today, but I would encourage you to go back and take a look at our examples and type each one in for yourself. Certainly the idea how the built-in globals can return a mutable dictionary to our global environment, and more interestingly, what happens when we provide our own dictionary to either an eval or an exec built-in operation. Thanks for listening. Thanks for listening, and report number 8 is well underway, and I am indeed looking forward to seeing you in the professional software development world.